Okay. Today we will discuss about one more organometallic reagent in organic synthesis. So the organometallic reagent is uh, organoaluminium compounds. So that means if there is any compound having a bond with the aluminum, more particularly carbon aluminum bond containing compounds are called organoaluminium compounds. And here carbon is bonded with electropositive atom aluminum. So what it means? It means that R is an alkyl or aryl or organic compound. So aluminum is a metal. And here, what is that? R will be in the electropositive and aluminum will be in the electronegative. Okay, right? So R will be in positive nature, aluminum will be negative nature. So therefore, R always acts as a uh, R always acts as a, it should not be nucleophile, no? It should be electrophile because it's accepting electron because R is a electropositive in nature. One minute. Aluminum. Okay. Anyway, maybe what you can say that in organoaluminium compounds, carbon is bonded to electropositive atom. So as per the words, aluminum should be what is called as delta plus. Okay, so that means R should be what is called as delta minus. Okay, so this maybe I will look into this plus and means electrophilic nature and nucleophilic nature. So I think you are aware about the lithium aluminum hydride, isn't it? So lithium aluminum hydride means H is in the form of minus, means hydride. So that means aluminum should be in the plus form. Okay, this delta plus and delta minus should be replaced. Okay, that's what you need to remember. Okay, R means R, if R is equal to H, that will act as a nucleophile. And aluminum act as a electrophile. It's fine. Words wise, it's right. Only this delta plus and delta minus need to be interchanged. So organo, okay, let's give an entry. Okay, so organoaluminium are excellent nucleophile, but weak base. Organoaluminium are excellent nucleophile. That means, so whatever the attached to the aluminum, those will act as a nucleophile. But they are base. Base means they will don't act as a base. So less basicity, further, the less basicity, okay. Further, the less basicity of this compound is due to electropositive character of aluminum. So which is less than magnesium and lithium. Organoaluminium compounds behaves as Lewis acid due to vacant p orbital. Organoaluminium compound behaves as a Lewis acid due to vacant p orbital on aluminum. To complete its octet, organoaluminium compounds exist as dimer, more particularly cyclic dimer, a trimer, or oligomer in the absence of solvents. So one example I am taking trimethyl alane. So here alane means aluminum. So that means aluminum is bonded to 3-methyl group. So then such compound name is called trimethyl alane. So that means trimethyl alane in benzene. So in benzene is a non-polar solvent. In benzene it is available as a dimer. Okay, so this is the structure. So CH3 thrice Al. So what will happen here? I think you are aware about what is called as banana bonds. So more particularly, three-centered two-electron bond. So banana bonds where you can find, maybe you can found in the borane. So this is also similar to borane. So what is happening here? This is a three-centered two-electron. That means only two electron is there, but it is a three-centered one. Three-centered two electron, two bonds are available in trimethyl alane. So with this, I will go to the next. Next, you can look into that similar to that dimer, trimer. So few more example I am taking. Here, dimethyl. Okay, so dimethyl. More particularly, you can also take diethyl. Diisobutyl aluminum hydride. So that means dimethyl or diisobutyl aluminum hydride as cyclic trimer in benzene. So this is the trimer. Okay. So this is one moiety, this is another moiety, this is one more moiety. That means it's a trimer. How it is available? So it will be available, I think you are, suppose if this R2 is equal to ethyl, then you can say that diethyl aluminum hydride. This is one part. So this is another part. This is another part. Means a trimer is joined in the form of six-membered ring called benzene. Okay, it's a trimer. Then alkynyl. So one more example I am taking, alkynyl. Alkynyl dialkyl alane. So alkynyl means double bond. Dialkyl means two alkyl groups. So that means uh, exists as a dimer and form vinyl bridge dimer. So that means I think you are aware about aluminum is bonded with alkynyl bond, alkynyl carbon, and also aluminum is bonded with two alkyl group. Such compounds are called alkynyl dialkyl alane. Alkynyl dialkyl alane. It's a dimer and it's form a vinyl bridge dimer. So that I will show you in the next. Okay, so look here. So this is the one. So name of this compound is called alkynyl dialkyl alane. So this is the alkynyl means this double bond containing moiety is called alkynyl. So this R2 it indicates that aluminum is bonded to 2R group. So it's called dialkyl. Alane means this aluminum when it is bonded with the three groups, it's called alane. So this alkynyl dialkyl halane, it will be forming a vinyl bridge. So you can observe that this is vinyl, this is also a vinyl. So this is called vinyl bridge. How it is forming? There will be a, I think this is what is called there will be a bond formation between the aluminum and this carbon. Similarly, between the aluminum and then this carbon. And this complete moiety is called alkynyl. This is alkynyl dialkyl alane. So alkynyl dialkyl alane. This is one moiety, this is another moiety. These two are in a vinyl bridge form. So this is the dimer. This is the availability of alkynyl dialkyl alane in this form, dimer form. Write the structure of alkynyl dialkyl alane. Then you should be able to write this particular one. So with this, I will take the examples. What are the different types of organo aluminum compounds are available? So next I will go over. So look here, there are three different. So one is this is a dialkyl aluminum hydride. So when R group is equal to alkyl group, then it's called dialkyl aluminum hydride. This we will discuss about its synthesis as well as its application in organic synthesis. Similarly, we are also discussing about alkynyl dialkyl alane. This group is called alkynyl, and here aluminum is bonded with two R group. It's a dialkyl alane. This is the one. This is one type of organoaluminium. This is another type, and this will be the one more type. Three different types of organoaluminium compounds are available. So name of this compound is trialkyl. This is 1, 2, 3. Trialkyl alane. So trialkyl alane, dialkyl aluminum hydride, and alkynyl dialkyl alane. So these are the different types of aluminum compounds. So with this, I will go to the next slide. So next is one about the preparation of. So preparation of dialkyl. R2 means dialkyl aluminum hydride. So dialkyl aluminum hydride. So what? Okay. So let us reduce a little bit. Okay, this is fine. So this is about, so here I am taking particular example, a particular kind of organoaluminium compound, dialkyl aluminum hydride. So dialkyl aluminum hydride is generally represented as R2ALH. So how one can prepare this R2ALH? So preparation of dialkyl aluminum hydride. So this name of R2Al, it's called dialkyl aluminum. So dialkyl aluminum, so more particularly two equivalents was taken. So this was treated with hydrogen. Hydrogen 3/2 part of the hydrogen, and it was treated with activated aluminum. So maybe you are aware about the difference between the activated and crude. Okay, so here the aluminum taken one is activated. I think you are aware about the charcoal. Charcoal also two kinds is there. Activated charcoal also available. So what is happening? There will be a reaction between the dialkyl aluminum, hydrogen, and activated aluminum. So the obtained product is called dialkyl aluminum hydride. So here I am not written hydride, that you have to take it out. So that means dialkyl aluminum hydride is the name of this compound. So that means dialkyl aluminum hydride is obtained by the reaction of dialkyl aluminum with hydrogen in presence of activated aluminum. Okay, that will be the in terms of words. So in place of suppose if we are taking dialkyl aluminum chloride, so the chloride can be replaced with the hydride. What it means? It means that a reaction of dialkyl aluminum chloride with a lithium hydride giving rise to dialkyl aluminum hydride. So of course, this is a byproduct. Lithium chloride is a byproduct. Let's not worry about that. So with this, let's go to the reaction of dialkyl aluminum hydride. So what is the here? So this is about the what is called as preparation. So that means preparation. It is possible in two methods. One is reaction of dialkyl aluminum with hydrogen in presence of activated aluminum, and other method is dialkyl aluminum chloride with lithium hydride. So these are the two methods. So now let's move on to the reactions. So reactions of dialkyl aluminum hydride. So here R2ALH. R2ALH means dialkyl aluminum hydride. So what will happen? So here this you think aware about. So let's write R2ALH in this form. So here I am writing R2Al and there will be a hydrogen bond. So what is happening here? This hydride will add to more indert carbon. And this bond pair picks up this aluminum metal. That what it means? It means that there will be a cyclic four-membered transition state. So there will be a bond formation between this hydrogen and this less substituted carbon. Is it less or more substituted one? So this should be more substituted, but this is since it is a aluminum, it is a bulky one, it cannot add to this more substituted carbon. It will add to less hindered carbon. So that is the reason we can say the stereo selectivity, regio selectivity. So the product obtained is this. What it means? It means that less hindered carbon occupies the aluminum bond formation. More hindered carbon attacked by H minus. So that's the thing you need to remember. So as per as reactions of dialkyl aluminum hydride. So this is nothing but a reduction only. So, but what is you are adding hydrogen in addition to aluminum metal. So what we can say that halohydrogenation. Okay, so that means you are adding hydrogen as well as aluminum to the alkene. Okay, so this is a general example. So let's take an example. Means let's take an example so that you will have an idea. Look here, this is one alkane. What is the name of this alkane? Isobutene. I think this is the one, the fragrance. Okay, when you are opening the knob of kitchen gas, LPG gas, no, there the fragrance because of this isobutene. So how you can get isobutene? Just take tertiary butanol, add 1 drop of sulfuric acid, there will be a fumes. That fumes is nothing but a white color fumes. It's nothing but a isobutene. So this isobutene, what you can observe, this carbon is less hindered, this carbon is more hindered. Here H will add to this carbon because it's more hindered one, and Al will add to this carbon because less hindered. So that is how a product. So what is the name of this product? Trialkyl alane. It's a general name. Specific I am not talking about. So this is a general name of this compound is trialkyl alane. And I'm also taking one more. I think you are aware about this moiety. It's a terpenoid. naturally occurring one. So here what you can observe, there are two double bonds. This is one double bond, this will be the one more double bond. Of course, this double bond is hindered, whereas this double bond is exocyclic double bond. It is away from the cyclic moiety. So this particular double bond reacts with the dibutyl isobutyl aluminum hydride. So diisobutyl aluminum hydride or isobutyl aluminum hydride, both are same. So if you are mentioning, that is more correct. So diisobutyl aluminum hydride is the one. So this will act as a source of H minus. So more particularly, H minus always attack to a more substituted carbon. Aluminum always attacks to a less substituted carbon. So that is how this product is obtained. I will also take two more examples. So look here. So here also two double bonds is there. This is exocyclic double bond and this is intracyclic double bond. Aluminum hydride, okay, diisobutyl aluminum hydride does not attack the intracyclic double bond. It will attack to the exocyclic double bond. So that you have to find out. So this carbon is more substituted carbon. This carbon is less substituted carbon. In other words, this carbon is hindered carbon. This carbon is less hindered carbon. So H minus will add to this carbon, more hindered carbon. Aluminum will add to less hindered carbon. So that is how a product is obtained. So look here I am taking one more example. Here also you can observe that a double bond here and also there is a double bond here. So this double bond is called what is called as away from maybe here what you can say that there is no hindrance compared to this double bond. To this double bond there is a hindrance. And that is the reason H will add to this carbon. It's a more substituted carbon or more hindered carbon. And aluminum will add to this carbon. So that is how a product is obtained. So this is about what is called reactions of diisobutyl aluminum hydride. Otherwise, what we can say that reactions of dialkyl aluminum hydride. So up to this we discussed about the types of aluminum organoaluminium compounds. So what is that dialkyl aluminum hydride? So we also discussed about the preparations of dialkyl aluminum hydride. We also discussed about the reactions of dialkyl aluminum hydride, more particularly addition to alkene. So let's take one more kind of reaction. So that is hydroalumination. So I told no. So what is happening? A hydride and aluminum. So both the things you are adding to the double bond. So that is the reason we can say that hydroalumination. That means hydro H as well as aluminum, both the things you are adding to a double bond or triple bond. So above one also we can say as a hydroalumination of alkene. Alkene means ALKENE. Whereas this one you should say that hydroalumination of alkynes because the reactants are triple bond containing ones. So what is happening here? A triple bond. Otherwise, diisobutyl aluminum hydride, when it is added to a triple bond or alkyne. So what is happening here? Again, same rule. H minus will add to the more hindered carbon. So R group is a more hindered compared to the hydrogen. Hydrogen is a small group. Okay. So Al will form a bond here. So what it means? You know that this is a triple bond is converted into double bond. What is the name of this compound? So this group is called alkenyl. This group is called alkenyl. And this one is dialkyl. Alene. A-L-A-N-E. Alene. So alkenyl, dialkyl, alane. So what it means? Addition of diisobutyl aluminum hydride to alkyne gives alkenyl, dialkyl, alane. Suppose one can frame a question on this. How do you synthesize alkenyl, dialkyl, alane? So you can mention this method. A alkyne, when it is treated with diisobutyl aluminum hydride, it gives alkenyl dialkyl alane. So this is a general example. So let's take a particular one. So particular one means if a propyl group, this is called propyl group. Propyl group means CH2, CH2, CH3. Okay, it's a propyl group. This is also a propyl group. That means it's a symmetrical alkyne. If it is a symmetrical, then hydrogen can add this carbon as well as this carbon. Since it is a symmetrical one. So what is the obtained? The obtained compound. Of course, this is an alkenyl, and here dialkyl alane. Alkenyl dialkyl alane is a general name for this moiety. And here I am not mentioning about the specific name. Okay. So here, look here, this is again, right. Okay, very good. So this is a unsymmetrical alkene. This is not the symmetrical. So look here, this group is called propyl group. This group is called methyl group. So since the propyl group attached to this carbon is more indebted. So that means H minus will add to this carbon. Aluminum will add to this carbon. So the product is this. This is about what is called as organoaluminium compounds, and we discussed about uh, more particularly what is called as different types. What are organoaluminium compounds? Different types of organoaluminium compounds. More particularly the dialkyl, dialkyl halenes, trialkyl halenes, alkenyl dialkyl halenes. So we also discussed about the synthesis or the preparation of dialkyl aluminum hydride. Uh, right. And also we discussed about the few reactions. So reactions means dialkyl alane hydride, dialkyl aluminum hydride. When it add to double bond, so it will give you hydroaluminated product. Similarly, uh, uh, dialkyl aluminum hydride, when it is added to triple bond, it gives alkenyl dialkyl alane as the product. So this is about today's class. Maybe I will uh, continue the next. I will remaining part of the organoaluminium compounds. I will take in the next class. If you have any doubts up to this,